In the darkness around Jupiter, a giant moon shines. A moon so large it dwarfs even the planet Mercury. This is Ganymede, the largest moon or satellite in our solar system, and it holds mysteries that have fascinated scientists for centuries. Ganymede isn't just big, it's gigantic. With a diameter of about 5,268 kilometers, it's larger than Mercury. If Ganymede orbited the Sun instead of Jupiter, we may have even called it a planet. But as one of Jupiter's 4 Galilean moons, it's forever bound in orbit around the giant planet, completing a lap every 7 days. This colossal moon was first spotted in 1610 by Galileo Galilei, alongside 3 other Jovian moons, in a discovery that revolutionized astronomy. For the first time, humanity saw moons orbiting another planet, proof that not everything in the cosmos revolved around the Earth. Galileo's discovery of Ganymede and its siblings Io, Europa, and Callisto helped open our eyes to a much bigger universe. Picture Galileo over 400 years ago, peering through his tiny telescope at Jupiter and seeing little stars dancing around him. He likely couldn't imagine the complex world that Ganymede truly is, a world that we're still uncovering today. Fast forward to the space age, we soon approached the Jupiter. In 1979, NASA's Voyager 1 and 2 zoomed past and snapped the first close-ups of Ganymede. Those images showed a mottled, icy surface with 2 distinct personalities: dark, heavily cratered regions and lighter, grooved regions, crisscrossed with ridges. These mysterious grooves suggested that Ganymede's icy crust had been fractured and resurfaced by geologic forces in the distant past. In other words, this moon wasn't just a dead rock. It had a history of tectonic activity. Scientists were eager to learn more, and Ganymede was about to get a visitor that would change our understanding of it. In the 1990s, NASA's Galileo spacecraft became the first to orbit Jupiter, and it flew by Ganymede several times. Galileo's instruments made a startling discovery. Ganymede has a magnetic field of its own. Imagine everyone's surprise. Moons aren't supposed to have magnetic fields, right? After all, a magnetic field like Earth's usually means you've got a molten metal core churning inside. And Ganymede indeed turned out to have a liquid iron core, making it the only moon known to generate a magnetosphere. In fact, Ganymede's magnetic field is so significant that it even outperforms Mercury's in strength, though it's still only about 1% as strong as Earth's. This intrinsic magnetism gives Ganymede a tiny protective bubble inside Jupiter's enormous magnetic field. When charged particles from the Sun and Jupiter slam into Ganymede's atmosphere, they create stunning auroras around Ganymede's poles, just like Earth's northern and southern lights. A moon with auroras? Yes, you heard that right. Ganymede indeed has its own northern lights. Galileo's magnetometer data also hinted at something hiding under Ganymede's ice. As the spacecraft flew by, it detected strange fluctuations in Ganymede's magnetic environment. To the scientists, this was a clue that something conductive was underneath the surface, possibly a layer of salt water. Maybe an underground ocean? It was an exciting idea. In fact, as far back as the 1970s, some researchers had suspected Ganymede might have a liquid interior, but now they had evidence. Still, the data wasn't conclusive. Galileo's snapshots of the magnetic field were very brief, and the case for Ganymede's hidden ocean would grow stronger in time. Meanwhile, Galileo's cameras and other instruments painted a richer picture of this moon. Ganymede's surface is a mix of water, ice, and rock. It's like a cosmic layer cake, an icy crust on top, a rocky mantle beneath, and as we now believe, a liquid water ocean sandwiched in between. The dark regions on Ganymede, such as a big one named Galileo Regio, are ancient and battered by meteor impacts, making them as old as the solar system. The lighter, grooved terrains are somewhat younger, their ridges and troughs hinting at upheavals that repaved parts of this moon. We see giant craters with starburst patterns of ejected ice and long cracks slicing across the land. Ganymede even has a very thin atmosphere made mostly of oxygen, though it's far too thin for us to breathe. It's the product of sunlight and particles hitting the ice and releasing molecules. So in short, Ganymede turned out to be a far more dynamic and interesting world than anyone had imagined from Earth. But the biggest surprise was still to come. It would take a telescope in Earth orbit and 2 decades of curiosity to finally confirm Ganymede's ocean. In 2015, scientists using the Hubble Space Telescope announced how they'd found the best evidence yet of a subterranean ocean on Ganymede. So how'd they do it? Not by looking inside Ganymede directly, but by watching its auroras. Here's the clever part. Ganymede's auroral bands, these glowing curtains of plasma, actually rock back and forth slightly as Jupiter's powerful magnetic field changes. If Ganymede were just solid rock and ice, the auroras would sway by a certain amount. But Hubble observed that the aurora motion was being dampened as the sun's unseen force was resisting Jupiter's influence. That unseen force was a secondary magnetic field created by a huge layer of electrically conductive fluid beneath the surface. In other words, a global saltwater ocean. By modeling the aurora motion, scientists estimated Ganymede's ocean might be 100 kilometers thick, buried under about 150 kilometers of ice, and it could contain more water than all of Earth's oceans combined. Just let that sink in. More water than Earth. However, this water is locked away under an icy crust in utter darkness, perhaps resembling the lightless abyssal seas on Earth if those seas were under miles of ceiling. This discovery became a game changer. Suddenly, Ganymede joined the exclusive club of ocean worlds in our solar system, moons and planets with hidden oceans that might, just maybe, harbor life. Europa, Ganymede's sister moon, and Saturn's moon Enceladus were already prime candidates, thanks to their thinner ice shells and, in Enceladus' case, geysers shooting water to space. Ganymede's ocean is very deeper, but it truly is gigantic. The prospect of such a vast water reservoir weighs new questions. What is the ocean like? Is it layered with ice? Is it in contact with the rocky seafloor? And most importantly, could anything be alive down there? Scientists caution that Ganymede's ocean might be sandwiched between ice layers, like a multi-tiered cake of ice and water, possibly making it tougher for any life to get nutrients or energy. Some models suggest Ganymede could have stacked oceans, for instance, ice, then water, then more ice, and maybe another layer of water. If true, the liquid layer might be separated from the rock below by ice, which is not ideal for sparking life's chemistry. The story isn't so simple. In 2021, new data emerged that gives us hope that Ganymede's ocean has interacted with the rock at some point. That year, NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, made a daring close flyby of Ganymede. It was the closest any spacecraft had come to Ganymede in more than 20 years, skimming by just 1,000 kilometers above the surface. Juno's main job at Jupiter is studying the planet. This flyby was kind of a bonus treat for moon fans. Juno's camera snapped stunning high-resolution images of Ganymede's cratered ice, and its scientific instruments probed the moon's composition. In late 2023, researchers announced exciting results from Juno's Ganymede encounter. They found salts and organic molecules on Ganymede's surface. Specifically, Juno's infrared spectrometer detected evidence that the surface in some region contains salty compounds and possibly organic carbon-based compounds. So why is that such a big deal? The answer is because those materials likely came from the ocean below, perhaps forced up through cracks or mixed into surface ice by impacts. Essentially, Juno found residue of an ocean brine that had made its way to the surface and evaporated. The salt is important. It suggests that Ganymede's ocean isn't just plain water, but salt water, much like Earth's ocean, which potentially is circulating through rock and picking up minerals. Even more intriguing, the organic compounds detected could be things like aliphatic aldehydes, not like themselves, but ingredients that under the right conditions can lead to amino acids and the building blocks of life. As one scientist put it, finding organics doesn't mean that life is there, but life requires some of those organic ingredients. So it's clear that Ganymede's ocean at least has the right chemistry at play. This is big news, literally fresh from Ganymede, telling us that this frozen moon is more chemically dynamic than we had realized. Shows us that Ganymede's ocean has, at least in the past, touched its rocky floor and brewed a chemical soup that includes salt and carbon compounds. Those conditions are thought to be necessary for habitability. So now we have a moon with a giant hidden ocean, a magnetic field, a sprinkle of atmosphere, and ingredients for life. So naturally, the next step is to go back and take a much closer look. Enter JUICE, the European Space Agency's Jupiter Icy Moons Explorer, launched in April 2023. This spacecraft is literally on its way to Jupiter right now. JUICE's mission is laser-focused on the three large icy moons, Callisto, Europa, and especially Ganymede. In fact, JUICE will do something that no spacecraft has ever done before. It will orbit Ganymede itself in the 2030s. After arriving at Jupiter in 2031 and conducting multiple flybys, JUICE is scheduled to settle into orbit around Ganymede by 2034, becoming the first probe to orbit a moon other than our own. For at least 9 months, it will circle Ganymede, mapping its surface in unprecedented detail, measuring the thickness of its ice crust, confirming the depth and saltiness of its ocean, and even probing the interior with ice-penetrating radar. Essentially, we're going to X-ray Ganymede to see what's inside. One of JUICE's main goals is to evaluate the habitability of Ganymede. So in other words, could this moon's environment ever support life? This mission is going to look for the building blocks of life, like the organics that Juno spotted, and try to answer whether those dark, deep oceans have the energy and nutrients needed for living organism. Now, of course, we don't know if anything lives in Ganymede's ocean. It's a tough place, deep, dark, likely cold, and under enormous pressure. Ganymede doesn't seem to have active geysers, at least none observed yet. And if life exists there, it might be microbial, eking out an existence near hypothetical hydrothermal vents on the ocean floor, perhaps using chemical energy from water reaction. That's a lot of ifs. It's also possible that Ganymede's ocean, sealed away and maybe layered with ice, is simply not as friendly to life as some other moon. But we are going to know until we look, and look we will. From Galileo's first glimpse through a telescope, Voyager's flyby photos, to Galileo the spacecraft finding a magnetic heartbeat, to Hubble confirming a vast ocean, to Juno detecting the chemistry of life, Ganymede has continually surprised us. It started just as a moon of Jupiter, and now we see it as a complex world of its own, one with a core, a magnetic field, an atmosphere, a hidden sea, and potential for alien life. Ganymede teaches us that even moons can be more than just sidekicks to their planet. They can be rich, dynamic worlds to themselves. So the next time you gaze up with a telescope, spot Jupiter's tiny points of light dancing around it, remember that one of those points is a colossal ocean moon that just might hold the ingredients for life. The largest satellite in the solar system is not just a background character in the story of planets, but a protagonist in the ongoing quest to find life beyond Earth. As new missions approach this giant moon, we're on the brink of writing the next chapter in Ganymede's story. So stay tuned. Ganymede's sequence will stay hidden forever, and what we discover there could redefine our understanding of life in the cosmos. Thank you very much for watching. If you've enjoyed this journey to Ganymede, please give the video a thumbs up and subscribe to Stellar Quest for more adventures across the cosmos. Until next time, stay curious.